Now let's talk about single element access of a string. Say our string s1 equal to goodbye and s12, which returns a reference to the character at the position 2. So this will return O. And if we do s12 equal to x, then we have a string of goxbye. If we do s1.add2 equal to y, then our string becomes goybye. Alright, D. So you might want to ask, are these two the same thing? They are very similar in that they both return a reference to a character inside a string, but they are not identical. If we do s1.add20, which is bigger than the size of the string, then this will throw an exception of out of range. But if we do s120, this does not throw exception. Instead, this is an undefined behavior. This kind of difference between the add function and the operator bracket is universal in all STL containers which are capable of random access. And if we do s1.front, this returns a reference to the first character, which is G. And if we do s1.back, which returns reference to the last character, E. s1.pushback, this will append the character of Z at the end of the string, and s1.popback, it will pop off the last character in the string. And s1.begin returns an iterator pointing to the beginning of the string. s1.end returns an iterator points to the end of the string. String provides these APIs just to be consistent with other STL containers. And one container that is very similar to string is vector. And like vector, a string doesn't have push front and pop front because these two functions are too expensive for string. And because of the support of iterator, we can construct a string with iterators. String s3 constructed from s1.begin, s1.begin plus 3, and s3 will contain goo. Now let's talk about ranged access of a string, and we'll mainly talk about 4 functions: assign, append, insert, replace, because these 4 functions have very similar syntax. Say we have another string s2 equal to Dragonland, and we do s1 dot assign s2. This will have the same effect of s1 equal to s2. So s1 will also contain Dragonland. But the benefit of using the assign function is it is more flexible. We can also do s1 assign s2 to 4. This will take a portion of s2, which is a length of 4 starting at position 2. So length of 4 starting at position 2 is eigen. So s1 will become eigen. We can also do s1.assign wisdom. So this function takes a C string as a parameter. So s1 becomes wisdom. We can also s1.assign wisdom 3. This will assign the first 3 characters of the C string to S1. So S1 contains with. Notice the difference between this code and this code. When the first parameter is a string, second parameter is the starting position, last parameter is the size. When the first parameter is a C string, the second parameter is a size. So if we do s1.assign s2 3, this is an error. This won't compile. But we can do s1.assign 3 x. Then s1 becomes xxx. If we do s1.assign a, b, c, this is an initializer list parameter, and s1 becomes abc. Let's comment out this one. So these are the different ways of using the assign function. The other 3 functions, append, insert, and replace, have very similar syntaxes. So I'll just give you a couple of examples. s1.append def. So this is similar syntax as this one. So s1 becomes a, b, c, d, e, f. If we do s1.insert 2, 2 is the starting position where you want to insert, let's say, mountain. 4 is the number of characters that will be inserted. So this will insert the 4 character of moun into the second position of s1 string. So s1 becomes a, b, mon, c, d, e, f. So this syntax is very similar to this one. And we can do s1.replace, and it will replace a portion of string inside s1 starting at position 2 with the size of 5, and we will replace it with a portion of s2 starting at position 3 and with the size of 3. So this portion of s1 will be replaced with this portion of s2. So s1 becomes a, b, gon, d, e, f. And as you see, this syntax is very similar to this syntax. So as long as you have learned how to use one function, you can pretty much guess how to use the other. There is another function called erase, which also take a position and a size. Let's say the position is 1 and the size is 4. And this is s1, position 1, size of 4 is this portion. So this portion will be erased from s1. As a result, s1 becomes a def. You probably have seen the pattern. Whenever you see 2 numbers as parameter, the first number is the position, the second number is the size. If we do s2.substring 2, 4, again the first number is the position and the second number is the size. So this will take a substring of s2 starting at position 2 with the size of 4. So it will return again. Now let's say s1 equal to abc and s1.c string. This will convert the string into a C string. So it will return abc with a null termination. If I do s1.data, in C++03, it will return a string without the null termination. But in C++11, it will also return a string with null termination. So after C++11, the C string function and the data function are synonymous. And lastly, there's a function called swap. This is another function that almost every STL container has. It swaps the two strings. Thank you for watching. Feel free to subscribe to my channel and check out the other videos I have. See you next time.